Okay, guys, how are you? I'm happy to be with you today. Today, I'm going to be talking to you about the reduced row echelon form and the row echelon form. So, our objectives for this lesson, inshallah, are by the end of this lesson, inshallah, you are going to write the linear equation in the matrix form, identify the augmented matrix, convert the augmented matrix into row echelon form or Gaussian elimination, convert the augmented matrix into reduced row echelon form or Gauss-Jordan elimination, solve the system of equations by making like back substitution. So I'm going to start with you with illustrative example. Here we have a system of linear equations, 2x minus 3y plus z equals 4, 4x plus 2y minus 7z equals 3, 2x plus 8y equals 1. Then I want to write the system of these linear equations into the form of matrix and into the augmented form. So into the form of matrix or the matrix form, I'm going to make this matrix and take the coefficients of x, y, and z and put them in a matrix. As you see here, we have 2, -3, 1, 4, 2, -7, 2, 8, and 0, as there is no z here or z is not exist. And a column vertex to represent the variables x, y, and z is equal to a column matrix to represent the constants 4, 3, and 1. Okay, then we say that ax equals b is called the matrix form of a system of linear equations in different variables. And for the augmented form or the augmented matrix, here we have, I'm going to put all the coefficients and the constants in one matrix, and there is a vertical dashed bar disjoin the constants from the other coefficients. And this is called the augmented form. So I'm going to move into the procedures of Gaussian elimination or reduced row echelon form for the augmented matrix. So if you format the augmented matrix, then you can multiply or divide any row by any scalar or constant. And you can also carry out operations on any row by making combination of this row and any other one. You can interchange the position of rows. You can exchange them, you can replace them. Also, then the leading entries are called the pivots. They must be ones. All the entries rather than the pivots must be zeros. The zero row, if exists, must be the last one. Then you get stair-step share of the augmented matrix, and eventually you get the reduced row echelon form on one of the following forms. Here we have 1, 0, A13, and these are the forms. I'm going to study them with you. Okay, then here we have one solution in this case, and no solution in this case, the upper and the lower case, and an infinite number of solutions in this case. When you reduce or transform or convert the augmented matrix in one of these formats, then if it is a system of two linear equations in two variables, then you will deal with this one. You will compare your result with this one, and then here we have 1x plus 0y is equal to this number 1 A13, and 0x plus 1 y is equal to a23. This means that x equals a13 and y equals a23, and this means that there is only one solution. What about the case that has no solution? In this case, we have, pay attention, 0x plus 0y equals 1. 0x plus 0y, which is 0, 0 equals 1. It is impossible, then there is no solution, and we see that the system is inconsistent. And here we have case number 3, an infinite number of solutions, that x plus y is equal to 0. Or in other words, we can say that the two linear equations are equivalent to only one equation. They are in two variables. Then here we have one equation in two variables. This means that one will take any or free to take any arbitrary value, and the other depend on it. Then we have independent value and dependent variable. Okay, let's complete and move into a comparison to figure out the difference between REF and RREF. What about REF, or row echelon form, or Gaussian elimination? This form or this figure gives you overall vision about the row echelon form, and here we have zeros down here and ones in the main diagonal. I'm dealing with these numbers, the coefficients only, and it is called, this matrix is called our triangular matrix for this part. Okay, then this is called the row echelon form. Then we can make different operations on the augmented matrix to convert it into the row echelon form. And then here we get x plus 5y plus 0z is equal to 2, y plus 3z equals -1, and z equals 4. Then by making back substitution, we get the answer. Okay. On the other hand, we have the reduced row echelon form, which is called sometimes Gauss-Jordan elimination. And here we have, you may, or you can, actually in some words, you can make different operations on the augmented matrix to convert it into this shape. And actually we have zeros on the upper and on the lower part of the matrix, and only once in the main diagonal. Then every pivot, we can say, in other words, that every pivot has different zeros upper and lower it, as you see in this matrix. Then only the pivots are ones and all the others are zeros, as possible as you can do it and convert it into this form, which is reduced row echelon form. And here we can get directly the answer that x is equal to 2, y is equal to -1, and z equals 4. Instead of making back substitution, you can get directly the answer. Okay. And let's move into a simple example. Okay, solving a system of linear equations in two variables. I'm going to start with you first with two variables, and after that I'll move on to the system of three variables in three given equations. So I'm starting with you with the unique solution. Here we have the first system, 2x minus y is equal to 1, x plus 2y equals 8. And I want to use a reduced row echelon form to solve this problem. You studied at grade 3 at the preparatory stage last year that you have algebraic solution and graphical solution. For the algebraic solution, we have the omitting method and also the substitution method. And for the algebraic one, we try to do the two equations and represent them by two lines and find out the intersection point of them, and this intersection point represent our solution. So starting with you with this, that this is the augmented matrix. Here we have 2, -1, 1 and 2, and here we have the 1 and 8, the constants. Then the way I'm going to use that, I must put here 1 instead of 2. Then I'm going to replace or interchange the second row with the first one. Then we get 1 to 8, 2, -1 and 1, as you see here. Then after that, I'm going to make this element be 0. So I'm going to multiply the first row by 2 and subtract or take away the second row from it. Okay, as you see here, 2 times the first row minus the second row, to R1 minus R2. Then the first row is still the same, and the second row becomes 2 times 1, 2 minus 2 is 0, 2 times 2, 4 minus -1, 5, 2 times 8, 16 minus 1 equals 15. Then after that, I'm going to make this 1, 5, make 5 as 1, okay? Then as this is the first pivot with the leading one, and the second pivot must be here, and the pivots must be 1s. Okay, so I'm going to divide this by 5, the second row. Then the first row is still the same, 1 to 8, and the second row will be 0, 1, and 3. After that, I'm going to convert 2 into 0. So I'm going to multiply the second row by 2 and take away the second row from the first row. So R1 minus 2, R2. Then here we get 1, 0, and 2, 0, 1, and 3 is still the same. Okay. And after that, after making this operation, then here we get x equals 2 and y equals 3. Then in this case, we can do different operations on the augmented matrix by multiplying the first or the second row, or dividing it as you see in this step, or replacing any two rows, okay, or interchanging their places as in this step. And also we can make a combination of two rows by multiplying one by a constant as you see here or here, and adding or subtracting it to another row. Okay, then this is valid for the augmented matrix and the steps we talked before. And also it is important to keep in mind that the leading pivot, or the start or the key here, this is called sometimes the key, must be 1, and all the pivots must be 1 as possible as you can. Okay, let's move on to, then here we have only a unique solution. Then this is the intersection point of the two lines 2 and 3. Let's move on to another example where case of no solutions. Okay, here we have this system, x minus 2y is equal to 3, -3x plus 6y equals -12. So I'm going to write down the augmented matrix. As you see here, 1, -2, the coefficients, and 3, the constant. In the second, the linear equation, here we have -3, 6, and -12. And I want to make -3 as a 0 zone. I'm going to multiply the first by 3 and add it to the second, multiply the first row, R1, 3, R1 plus R2, then we get 1, -2, and 3. This is still the same. And the second row will be 2 times 3 times 1, 3 minus plus -3 is 0. 3 times -2, -6 plus 6 is 0. 3 times 3, 9 plus -12, -3. After that, I'm going to, then here we get 1x. Then we don't have any other choices to make for this augmented matrix to translate or convert it into this form as you see here. Then here we stop. We don't have any other choices. Then here we get x minus 2y is equal to 3. It is a reasonable solution. But for the second row here, we get 0x plus 0y equals negative 3. And this means that 0 equals negative 3. And this is impossible. And this means that there is no solution between the two linear equations. And this is impossible. Then there is no solution. And this is very, very obvious. If you divided the second linear equation by negative 3, then you will get x minus 2y equals 4, and the first one is x minus 2y equals 3. They are the same, but they are different in the constant. This means that the two equations have the same slope, but they don't pass through the same points. And this means that the two lines represent these two equations are parallel. Okay, they are parallel. This means that there is no intersection point between them. For the second example here, solves the linear system. In this case, we have three linear equations in three variables. Then I'm going to move into a bigger example or more wide thinking. In this case, then our augmented matrix will be on this form. The coefficients are 2, 6, 1, and the constant is 7. For the second one, 1, 2, negative 1, and the constant is negative 1. And for the third matrix, for the third line, here we have 5, 7, and negative 4, and 9. As I told you before, that you must start with the leading one, or the pivot must be 1. Here we have two choices. Either you are going to divide the first row by 2, or replace the first row with the second row. Then you will ensure that you will have the first leading is 1. Then by interchanging the places of the first and second rows, then here we get 1, 2, negative 1, and negative 1. And in the second one, 2, 6, 1, and 7. And in the third one here, you still have this row. And actually, this is valid. You can interchange, as I told you before. And then after that, you want to make this item or this entry B0 and also 5B0. So I'm going to multiply the first row by negative 2 and add it to the second row, and also multiply the first row by negative 5 and add it to the second row to guarantee that this is 2B0 and 5 will be 0. Here the first row is still the same, 1, 2, negative 1, negative 1. And the second row will be negative 2 times 1, negative 2 plus 2 is 0, negative 2 times 2 equals negative 4, negative 4 plus 6 equals 2. As you see here, negative 2 times negative 1 is 2 plus 1 equals 3. Negative 2 times negative 1 equals 2. 2 plus 7 equals 9, as you see here. And also you can make the same technique actually with the third row and get 0, negative 3, 1, and 14. After that, I want to take or to make 2B1. I want to make it B1. So I'm going to divide the second row by 2, have R2. Then here we get the first is still the same, the last is still the same, and the middle row divided by 2. Then we get 0, 1, 3 over 2, and 9 over 2, as you see here. And then after that, I want to make a negative 3 as 0. Then I'm going to multiply the second by 3 and add it to the third row. Then the first is still the same, the second is still the same, and the last will be 0, 0, 11 over 2, 55 over 2. And then after that, I want to make 11 over 2 B1. So I'm going to multiply the third row by 2 over 11. Then we get the first is still the same, the second is still the same, and the third will be 0, 0, 1, and 5. And this is called the row echelon form. Okay, then directly we can get the answer that z equals 5, y plus 3 over 2, z equals 9 over 2, and x plus 2y minus z is equal to -1. Okay, and by making back substitution, then we get x equals 10. If I plug in 5 here, then 3 times 5, 15 over 2, y plus 15 over 2 equals 9 over 2. By moving 15 over 2 to the other side, then 9 minus 15, which is equal -6 over 2, -3, then y equals -3. And by plugging here 5 and here we put down -3, then 2 times -3, -6, -6, -5, -11, and move it to the other side to be +11 minus 1 equals 10. Okay, then we get x10. After that, I'm going to convert the row echelon form to the reduced row echelon form by trying to make 2 becomes 0, this item be 0, and this item be 0, this one be 0. All the other elements except the diagonal ones will be 0, and this is what I'm going to do now. Here, by getting back to the row echelon form, then by multiplying the second one, the second row by -2 and adding it to the first row, then the second and the third rows are still the same. And for the first row, then here we have 1 and 2, -2 times 1, -2 plus 2 equals 0. -2 times 2 over 2 is -6. -6 plus -1 negative again -2 times 3 over 2 -3, I'm so sorry, plus -1 -4, -2 times 9 over 2 is -9 plus -1 -10. Okay, -10. Then the others, the second and the third rows are still the same. Then after that, I'm going to multiply the third row by -3 over 2 and add it to the second one, and also multiply the third one by 4 and add it to the first row to get rid of -4 and or to wipe out -4 and wipe out 3 over 2. Then the third one is still the same, and the second and the first ones are converted into this figure. This is like the identity matrix. Okay, for this part, I'm talking about this part of the matrix, not all the matrix. Okay, and then we get the answer directly that z equals 5 and x equals -3, y equals -3, and x actually equals 10. And this is typically is the same as the answer we get before in the row echelon form. By making back substitution, they are the same. After that, I'm going to move into another example number 3, an infinite number of solutions. In this case, I'm going to give you 3 different linear equations and trying to put them on the augmented matrix and convert them to the row echelon form, and actually move into the reduced row echelon form. After that, so I'm going to start with you with this augmented matrix. So here we have the coefficients of the linear equations and the constants, as I told you before. Then here we have here 1 as a leading one or a pivot, and here we have 4 and 2. Then first of all, I'm going to multiply the first by -2 and add it to the last row or the third one, and also multiply the first by -4 and add it to the second row, and then the first row is still the same as you see here, and the second and the third rows are -0, -11, 11, and 33, 0, -11, 11, and 33. You actually knew the technique you can use to do these operations, and I'm not going to repeat what I said before in this example. You can pause the video and make sure of your computations, and you can write down your computations on a piece of paper and compare between you get and the answer here on the screen. After that, I'm going to uh, divide the second and the third rules by -11 to trying to put it onto the rule echelon form, and then I'll get this form 0. The first rule actually is still the same, and the second 0, 1, -1, and -3, and third is 0, 1, -1, and -3. Actually, the second and third rules are the same. So after that, I'm trying to make this as you see here, we have 1, and want to make this 0. So I'm going to multiply the third by -3 and add it to the first, okay, to get zeros here. And let's see how to do this. Multiply the second by -3 and add it to the first one. Multiply the second by -3. Then here we get -3 plus 3 is equal to, as I told you, multiply the second by -3 and add it to the first one to get here 0. So here we have the second will still the same. Then the first will be 1, 0, 1, and 2. And what about the third one? I'm going to add the second and the third one, but after multiplying by the second by -1, then here we get zeros here. This is called the reduced row echelon form. And pay attention, look intently at this information here we get. Then here we get at the last rule, all the last rule are zeros. So the three equations here are equivalent to only 2 equations. So what I can say is that here we get the pivot column. Here we get 1, here we get 1. Here it must be 1, but we don't have here 1. So what I can say is that, in other words, that this is called a pivot column, the first pivot column, and this is called the second pivot column, and this is called the third but not pivot column. It is called a free pivot column for Z. This represents the X column. This is Y column in which there is a pivot, and this is Z column in which there is no pivot. This is called a free column, and here Z is free to take any arbitrary value, and we can say that Z equals T, and actually we can find out X in terms of T and Y in terms of T. So let's say that Z equals T, then X plus T equals 2, then we can say that in different words that X equals 2 minus T, Y minus T equals -3, and here Y equals T minus 3 or -3 plus T, and T any value. Then here we have an infinite number of solutions. Whatever the value of T, then we get values for X and Y corresponding values. And this arises when we get one of the equations is a combination of the other 2 equations. You can get it easily, okay? Then this is the case of where there is an infinite number of solutions, okay? Let's move on to the last example, example number 4. In case of no solutions, here we have using the reduced row echelon form to solve X plus, this is the system of equations, X plus Y plus Z equals 3, Y minus 3Z equals -11, 2X plus Y plus 5Z equals 18. So I'm going to put down the augmented matrix and trying to convert it to the reduced row echelon form. So I'm going to multiply the first row by -2 and add it to the third one. Then here we get, and also And here we get the first, the second row is still the same, and also subtracting the second row from the first one, and here we get this matrix 1, 0, 4, and 14, 0, 1, negative 3, and negative 11, 0, negative 1, 3, and 12. You can pause the video and try to make these combinations and compute them away in your paper. And after that, what I want to make this element 1, or enter 1, 0, 0 here, and here we still have a 1, and 0 upper and 0 lower, and here we have 1 and 0 and 0 upper and up. Okay, this is the technique I'm going to try to reach, or the form I'm going to, sorry, the form I'm going to try to reach. Okay, after that, here we get this form by adding the second, sorry, and the third rows. The second and third, they cancel out each other. Then here we get 0 for the last one, and replacing it for the last one. Then the first is still the same, and the second is still the same. And only I'm talking about the third. I'm going to replace the third row with this combination by adding the second and third one. Then here we get 0, 0, and 1. And as we saw before, add the system of two linear equations in two variables. If you have 0 equals 1, then it is impossible. Okay. After that, I'm going to move into my computations, and I'm going to subtract the first row minus 14, the third row, and the second row plus 11, the third one, to get the reduced row echelon form as you see here. Then here you have 0x plus 0y plus 0z equals 1. And this means that 0 equals 1, and it is impossible. So then there is no solution. Okay. I'm done now. Mr. Hussam Shirbini was talking to you. Until the next time, see you. Bye bye.